Okay, great. So, yes, first of all, welcome to all of you for our CCNA session. Myself, Kevin, I'll be your trainer for this particular course. So, as you know, CCNA is one of the beginners course for networking. And over here, we are going to just jump into what exactly is happening inside the whole networking profile. So how to do this, what are the basic devices as well as types of routing, configuration, everything. So during the time of this particular course, we will be going through each one of them one by one. Okay, so I can see a lot of people already joined in, around 30. Great. Good to see. So yes, uh, so I won't be going into like each of your names and everything because I can see most of your names over here. During the course time, whenever you have any doubts, feel free to ask it. And I believe that time we can just go ahead and introduce ourselves to each other. Mainly because if you have these many people, if you're going into introduction, within that time itself, we just have 1 hour for the session. That will be over there. Okay. So once again, welcome to our session. So yes, I'll just share my screen and we can go ahead and slowly start with our session. So before starting, I'll just give you a brief intro into the whole CCNA profile, what you can do with Cisco, etc. Okay, so let me share my screen. Do let me know once you're able to see it. Hope the screen is visible to all of you.
Yes.
Yes, thanks for confirming.
Yes, we can.
Yeah, please well.
Excellent. Yes. So, first of all, as you can see over here, that's me, my name. No, I mean, the image is not me. My name is Kevin, and this is our course that we'll be going through in this particular session, that is implementing and administering Cisco solutions. That is CCNA. So, right now, our course has been updated. So, the one that we will be following is CCNA 2.0, which has been updated by Cisco in 2022 towards the end of 2022. So we have practically have the latest curriculum with us right now. So that will be taken for our session. And CCNA is obviously the first step into your entire networking career, basically. So you have the option to go through different tracks within networking itself. Because so I'll just show that to you. Okay. So over here, you can see different options that you have. So as you can see, the bottom one that you see over here, that is CCNA, which is the short form for Cisco Certified Network Associate. So that is the level 1 that you have. We actually have something else that is CCNT, that is a technician level certification. But most people, like the most companies, do prefer CCNA as like a beginning stage. So that's why we also prefer to go with CCNA. And for this CCNA, what you basically have is one single exam. So all the content, everything will be covered by us. Your requirement will be to go for the exam after this particular session. So the exam is the code you can see over here, 200-301. It will be a complete multiple choice questions. To put it simply, any exam till CCNP is completely just multiple choice questions. There won't be anything more than that over there. Okay. So yes, as I was saying, so this CCNA is basically where you begin your track. After that, you have the option to choose which track that you want to go to. So some of the major tracks are mentioned here. One is enterprise, then you have security, service provider, collaboration, data center, and DevNet. So DevNet is something new. And we also have something known as CyberOps, which is just like introduced, but it's not stable yet. So we are not going too much over there. So yes, these certifications has been introduced as different tracks. So for that, what you basically have to do is you have to get a core exam for enterprise security. So each of them will be having separate exams. So after CCNA, what you can do is you can choose whichever track that you want to go. For example, if you're choosing enterprise, what happens is you will have a core exam that is known as NCore. So it's mentioned over here. Okay, so same exam. You can go for that NCore and you will be provided with a certification which is known as specialist. After specialist, the next level is you can go for that NCore or along with a concentration exam, which is kind of like an optional exam that you can go for. You'll be given with multiple options, like at least 6 or 7 exams will be there. Whichever one that you want to choose, you can go for that. So you take one of that more. So basically, you'll write 2 more exams. When you get those 2 certifications, you will be in professional level certified uh, like proficiency, the Cisco Certified Network Professional. After that, next is where the whole lab and everything comes in. That is CCIE. So if you want to get CCIE, that is an expert level exam. For that, what you have to do is you will need the core exam. That is in this case N core, S core, SP core, etc. Any one of those exams. Along with that, you will have to sit in for an 8-hour lab. Okay, so that is how you get a expert level certification. So I just wanted to show you the track and everything that you have over here, out of which you can choose whichever field that you prefer. So if you are going for security level, you can go for this particular option, go for S core and any concentration exam. So that is completely up to you. Okay. And when it comes to Cisco, what you have to, like CCNA exam and all, what you have to know is your requirement is 82 percentage, close to 82 percentage for the exam, which I can assure you, like after you have completed a session with us, you will be pretty much good with that. Maybe practice for a couple of weeks for the different types of questions. And I'll assure you, you'll be getting certified right after if you're going for the exam. So no worries on that. So these are some of the tracks that you have. I just wanted to introduce it to you. Like some people might be knowing, some people might not be. So this is something that you can check. You can just do a Google search and pretty much get all these details over there. Okay, so no worries on that. And if you're still having any doubts regarding this, feel free to ask to me during any of our sessions. I'll be happy to explain. Just hold on 1 second. Yeah, sorry about that. Okay, I can see it chat. All sessions are recorded. Okay, got it. Okay, so I'm back. So that's it about the tracks and everything that you can go for. You can see it. Chat. Okay. So so let's just jump into our modules and everything. So in CCNA, you basically have main 6 modules and 1 set of labs. Okay, so these will be the major modules that you'll be having. That is network fundamentals, where you'll be going through some of the basic things on network requirements, like different types of components. What are the different types of IP like that is available? What are the different layers that you have? Then OSI model, TCP/IP, those kind of concepts you'll be going over there. Then you have network access, which is the next level where you would be a bit more like exposed towards the whole networking concepts. Then you'll be looking into IP connectivity and IP services, where you'll get a bit more understanding on different forms of connectivity, routing requirements, switching, VLANs, etc. Then you'll look into security fundamentals, where you'll learn how to set up different types of configurations on systems, how to add remote access, how to secure them using passwords, like your network devices, and also like an introduction to automation and programmability. So nowadays, basically everything is moved into automation, AI, and etc. Right? So we have one small module based on that as well, where you'll get a small idea on how to automate or how to set up a script or how to add a Python program or APIs, etc. So these are some topics that we'll be covering over here mainly. And seventh, so that's not a separate module itself. It will be part of our all 6 modules. That is, we'll be having industry-oriented lab practices. You'll be provided with a few packets and all. So my suggestion is please make sure that all of you have packet tracer installed on your system. Okay. because most of the labs we will try to do on packet tracer because I want to make sure that all of you are a bit more experienced on hands-on applications with yourselves. So you don't have to depend upon any external portal or anything. So please try to make sure that you have packet tracer installed on your system because for CCNA labs, that is more than enough. And I'll be able to provide you with the required packets and everything. So you can download it and try it on your system. Okay, so yes, so it doesn't take much. Like packet tracer is free to download, and it takes like very less memory. So if you have a system, it's much easy to set up. Any doubts regarding that during our lab time, feel free to ask. I'll help you on installing or setting up the account. Okay, I hope that's clear. So let's do one thing. Let's slowly jump into our session. So for that, I do prefer using a whiteboard more than slides because if I'm just using slides, it will be me trying to explain something, just looking at something. So let's jump in. Okay. So the first thing that I would like to explain over here are, or that I'd like to look into over here. Srinivas, okay, you can't hear about hands-on experience. Okay, if you're talking about lab, what I'm planning to do is I'm going to help you set up your own platform on your system where you can do the lab whenever you want. Okay, so you won't be limited by any other internet or anything like that. All you will be requiring is this particular software installed on your system, which is known as Packet Tracer. Okay, this is Cisco's Packet Tracer, something officially provided by Cisco. So using that, I'll help you to implement networks, troubleshoot networks, identify issues on network, and even like work on different large topologies as well. So it will give you a better idea on how to work on different scenarios. I hope you got it. Sure, no worries. Okay, so yes, coming back. So what we're gonna do is we're gonna look into like some of the concepts that are required over here, like when you're starting with a computer network. So let me just write something. So as you know, our course is CCNA, and what we're going to start with, let's start with the basics. So what exactly is a computer network? Okay. Uh, So what exactly is this computer network? So to put it simply, this word, that network, that has been used in like a lot of different aspects. For example, nowadays, networks can be considered as social networks, phone networks, television networks, or even for AI and all, we are calling it as a neural network. Okay, so out of this, there is something in common. A network is basically a system of connected elements that operate together. So in any case, so if you're considering social network, it is connecting a lot of people. Phone networks connecting all these analog devices. Television network connecting all these TV using set-top boxes and everything. When they're broadcasting, we are getting everything. Neural networks connecting patterns over there. So everything, the main major thing that you have to note about network is that they try to connect different types of elements together so that they can share or operate together. So that is the major thing. So when you're coming to computer network, it connects what? PCs, printers, servers, phones, cameras. So any kind of input output devices or storage devices, etc. So that is what basically a computer network does. It helps us to share resources and connect different devices so that we have the option to use them all together inside one location. So a computer network connects devices that allows them to exchange data with each other, which basically facilitates information and resource sharing. So that is the basic thing that you have to know about computer networks. Okay. So for example, in a house, like if you're considering a house, this computer allows family members to like share files, print documents on like network printers and all if you have that. And on TV, you can like play movies or other medias which are stored into your computer, like screen sharing or casting, etc. So all of these can be considered as network. Okay, it's not limited to like connecting through Wi-Fi or anything. So if you are having a phone and if you are having a laptop, you're connecting it using Bluetooth. That's a network. Any kind of connection that you are establishing with another device, you can assume that as a network. Okay. So nowadays we have expanded it to a huge area like internet and everything. But you can always assume any kind of connection that you're doing with any other device or multiple devices are involved, that you can consider it as a network, however small it may be. So that is in a home environment. So let's assume in a business environment. Somebody was off mute. Do you have any doubts? Like from what I'm discussing, if I'm going too fast, please let me know. Okay. Uh, so I'm guessing everything is okay.
Yes, sir.
Guys, feel free to come
Yeah,
off
sure,
mute.
sir.
Okay, no worries on that. Okay, thank you. So yes, let's come back in. So let's consider a business environment. So you may have many types of business operations like marketing, sales, IT, etc. So all these areas, you need to develop applications that allow information to be like collected, processed, etc. Which basically means you require some kind of devices to establish connection with other devices. Like if you want to share data, either you have to do that or you'll have to use some kind of sorry, not network, some kind of storage devices like pen drives, hard disks, etc. But it is not always feasible, right? Like if you're using a pen drive for all kind of data transfer, it's not easy. You'll have to keep on plugging it in, copy it, go over there, plug it in, then copy to the other device, etc. And that can also like result in chances of security issues, security breaches, etc., which we will discuss later. So for the time being, let's go over here. So in those cases, what you need some kind of connection. So even in case of employees, if employees needs to work together to share data and everything, they need some sort of infrastructure where they can share data, exchange information, etc. So that is basically where our network comes in. So this network allows multiple devices like laptops, mobiles, servers, shared storage, etc. to exchange information with each other. So there are basically like a lot of different components connected to each, which are necessary to like communicate with each other. So for these kind of requirements, we have a lot of different devices like routers, switches, etc., which we use to connect different devices together, bring them together. Because if you just go ahead and connect one PC to another PC or a PC to phone directly, you'll have some kind of limitation of how much data you can transfer, the kind of speed you will get over there. So over there, what we do is we will be including some other elements in between to make sure that we can have multiple devices come together. If not, for example, you want to connect five PCs together, but your system will only be having one like interface, that is Ethernet cable port or something like that. From that, you can't connect to five PCs, right? From one system. So in those cases, we'll be adding something like this in between and then connect all these devices to that particular intermediate device like routers, switches, etc. So based on the size of that particular network, we have different names for it. So basically, some of the major ones that we have are LAN, MAN, and you might be knowing this WAN. These are some of the major ones that you know. And there are a few others also when it comes to these kinds of different types of networks. For example, let's say uh, you might be thinking LAN is the smallest one, right? LAN is small, but at the same time, we have something smaller than LAN like SOHO. So we'll come to that. So before that, first of all, LAN, which is local access network. In most cases, LAN just means like we'll be having a network in a small geographical span. So maybe like one small office or one building. So any kind of network that is completely limited to a small geographical area can be considered as a LAN. Okay, we have something coming up. Limited area, yes, obviously. So that's right. A very small area, like geographically, will be used for that particular one. So, for example, as I just mentioned, you have a building or maybe a university or a college. So, any connections that happening within that particular college, university, or a building, or a business, or an organization, etc., can be considered as a LAN. Okay. Then you have MAN, which is Metropolitan Area Network, which is a slightly larger one than MAN, but not too much. So here it will be somewhere between one town to one city kind of a network. So basically, imagine that you're from, let's say, I hope you're not from India. So let's say a metropolitan city, yes, Bangalore. So imagine that you're from Bangalore. So if you have a network which you use to connect all the devices and everything from that particular metropolitan area. So all devices inside that metropolitan area, Bangalore city is connected together. You can consider that as a MAN. Okay, so these are mostly used by some kind of organizations. For example, if you have a police force or something like that. So if you have Bangalore police force, so they have to connect all their systems together and they don't want anybody else to have access to their network. Okay, so in that case, what they do, because they have a larger area, they have to cover that entire town or that entire city. So in that case, they'll be setting up these forms of networks. Okay, so these kind of networks, which is covering a larger area than land, but not too much, a bit limited by geography again. So these kind of networks are known as MAN. Cable television can be an example, but nowadays, thanks to the whole dish and everything, all the channels and everything are being connected together. But when you're talking about cable, then yes, cable television can be an example. Depends upon the kind of like channels over there. There are few channels that are only available on that particular kind of television. That definitely yes, you can consider that as an example. For multicasting those kind of requirements. Yes. Great example. Thank you, Subramani. Yep. Uh, then you have WAN, which is basically a wide area network and not really limited by geographical area. To put it simply, internet is a large WAN. Okay, so this is not really limited by any kind of geographical requirement. WANs can connect any devices like over as long as distance you want. You can go through different service providers even. It doesn't matter. So basically, to put it simply, the easiest example for WAN will be uh, the internet. And you have other kinds of WAN where imagine a situation where you have a company which has location in multiple countries. So you have one office in India, another office in US, another office in Australia, something like that. So these companies can also set up WANs with the help of different types of devices. So nowadays, one of the common method that not we, they use are implementing something known as an SD WAN, which is known as like defined WAN. Helps people to connect long distance WANs together. I mean, long distance network together to like form a WAN. So these are some of the major types of networks. And okay, I mentioned SOHO earlier. This basically means a small office, home office. So this is kind of like a smaller LAN. To put it simply, this will be restricted pretty much to maybe one room. That kind of a network is known as SOHO network. mainly used to connect a small office, like if you're working from home or something. So you might be having a laptop, you might be having a couple of like maybe a phone or a network device inside your home office. Okay, so that network where you have your phone, laptop, everything connected together, that you can consider as a SOHO network. Or to put it simply, you're sitting at home, right? So you might be having your laptop connected to your Wi-Fi. Your mobile should be connected, like might be connected to your Wi-Fi, and maybe your brother or your sister, your family member, somebody will be having different network devices, maybe a phone, laptop, something like that. So all of these are connected to your Wi-Fi router or your Wi-Fi modem, right? So that all bring together, like come together as a small SOHO network because all of them are connected to the same network, which is in a very small area, like in the premises of your house. If you go to the like maybe 10-20 meters outside your house, that network is lost. Right. So these kind of connections, which is pretty much limited to very small area, can be considered as SOHO. In most cases, these are limited to let's say 20 to 30 meters square. Just that. So these kind of connections are known as SOHO networks. So I hope you got an idea on what are these different types of networks that we have. And in case of like CCNA, we will be mainly concentrating on LAN. That will be our main concentration. Yes, definitely. That's a very good example. Mobile hotspot can be considered as a SOHO network. Okay, like very limited space, you'll be having a couple of devices, maybe up to what, 4 or 5 devices connected. Because on phone, I think the maximum number of devices that you can connect is around 6 to 8, depends upon which phone you have. So that's a very good example. Mobile hotspot can be considered as a SOHO network. Great job. Okay. So I hope you got the concept of it at least. Great. So that is the different types of networks that I want you to know about. Then let's say what are some of the uh, components that are part of our network. So first of all, the main thing that you want to know are what are the different types of network devices. Okay, so let's go over there. Network. So to put it simply, a network can be simple as two pieces connected together, or a complex as like several thousand devices that are connected together using different types of medias, devices, etc. So the elements that form a network can be roughly divided mainly into three categories. Okay, that is three types. So what are these elements? So the first one is devices. Second one is media. And the third one is services. Services. So these are the major three types of items that you have inside your network. So, okay, let's change the heading. We don't want network devices. We can make it into network components. That should be better. Components. That's a bit more better, like apt word for this. So you have devices, media, and services, out of which devices are interconnected with the help of media, which provides a channel for our data to travel to the destination. So that is basically how the network works. So you'll be having different devices. So maybe a computer over here, through which uh, you have to implement the connection between them. For that, you have the media. So you get, I think you got what the media is. Any kind of cable or wireless, Wi-Fi, anything which we use to connect multiple devices together, that can be considered as a media. So for example, if you're having a LAN cable, RJ45 cables, so those items, or you have Wi-Fi, Bluetooth, coaxial cables. So all of these kind of items can be considered as media. Uh, Plex. Um, is that a media server? Not really sure what you meant by Plex, to be honest. Here in this case, when I'm talking about media, it just means, okay, fiber passcode, yes, obviously that can be considered. The thing about Plex, I'll have to check. I'm not really sure what that is, to be honest. So fiber passcode can be considered RJ45 cable. So any kind of cables or any kind of item that you can use to connect between two network devices or any two devices to form a connection can be considered as a media. Okay. And when it comes to devices, it can be either two endpoint devices like your two PCs or from between a PC and a router or a switch. So it can be any kind of device. So we'll come to that because device also will be like splitting it into different items, to be honest. Uh, and then you have services, basically meaning any kind of action that can take place over there. So for example, if I'm transferring data from here to here, so for that, I'll be requiring some form of services. So if I'm transferring file, I can use file transfer protocol, that is FTP. Or if I want to access this computer and run a program over here. So there is a process running over there. So that can be considered as a service. So any kind of an action or any kind of an event can be considered as a service. Or like if I have an IP phone, I can like have this phone over here. And from this phone, I can call to another IP phone over here. So we are making a call using the IP phones, VoIP phones, it is known as VoIP, Voice over Internet Protocol. So these kind of like events or these kind of actions that you can do over the network can be considered as services. Even setting up a cloud or a server or making a video call like this. So this is a service. Like you're watching through the Zoom, right? Right now, I think so. So I'm giving you a like lecture using a video call. So here I'm using internet and I'm sharing resources from my side to you. So this can be considered as a service. Okay, so any kind of services or any kind of action, etc., can be considered as a service. So we have device, media, service. Devices are the actual, well, the name suggests devices itself. You have computer, you have switch, you have router, access point, firewall, IPS, etc. Any of these can be considered as devices. Then you have media, wires, wireless media like Wi-Fi, Bluetooth, etc. So coaxial cable, all of them. Services, any kind of events or actions. Okay, so let's go a bit into this. So when you're talking about actually devices, you basically have different types of devices. Mainly you have two types of devices. One is endpoint, the other one is intermediary. Okay, so end point and intermediary. So just like the name suggests over here, endpoint devices are the devices you can basically view at the end of any network. For example, so if you're using a laptop, it is at the end of a network, right? Because you are the end person, the user who is having access to that particular device. How client can transfer data from another country to our country through FTP. So we have options for that, like using IPsec, VPN, etc. Uh, what you basically do is you'll establish a private network, virtual private network, using IPsec, VPN, GRE, etc. So these are different methods which we will discuss during our course session itself. So using that, you can transfer data using FTP. There is no issues. You will establish that service between these two different locations, two client devices. Like you'll be having a system, he'll be having a system. You'll be establishing that connection between each of them. You can transfer the data. There is no issues on that. Okay, so no worries. You have the options for such requirements. There are even like different applications which you can use for this. And even client data in most cases nowadays, we are not even sharing through FTP. We'll be sharing through shared spaces. So you'll be storing it in a server. The other person can access the same thing on a server or set up a shared folder, anything like that. So we have multiple options to do that. Okay, coming back. Endpoint devices are basically any kind of devices you basically identify at the end of a network. SharePoint is one of them. Yes, you can use that. Depends, if you're mostly SharePoint is used by like company people, like for industrial requirements mainly because at times I think it is a bit paid over there. So you also have free resources like that. You might have to do some configuration requirements, but yeah, there are. Okay, and back. And for example, I can say laptop, tablet, printers. Okay, I'll do one thing. I have a example over here, which should be much easier for you to understand. Yeah, there we go. I think should be better for you to, view at least. So these are the two types of devices that you have, endpoint devices and intermediary devices. So when it comes to endpoint devices, you have laptop, tablet, printer, virtual server, phone, present. So any kind of input or output devices or a storage devices, okay, can be considered as endpoint devices. The reason we are saying it as an endpoint is because, like, if you have a network, something like this, these devices will basically be at the end of it. So if you have a laptop, you have a laptop over here and it will be only having one end. We won't be having another connection coming to the laptop from somewhere else. That won't be happening. Or if you have a server over here, you'll be having one connection coming from one router. We won't be having another router coming into that server. Only one device at the end. Okay. So for example, IP cameras. You might have seen CCTV cameras, right? So it will be connected to some kind of switch or a router or something like that. And to one camera, you'll be only having one connection coming in. Right. At the same time, if you're considering intermediary devices, it is used to connect all these different devices together. So these endpoint devices, they have a separate function. They have their own specific function, which is connected to the network so that the user can have access to its like resources or have access to their functions, laptops, tablet, printer, etc. Whereas when it comes to intermediate devices, their only requirement is to enable connection between these endpoint devices or other intermediary devices. Okay. So for example, you have different types of switches like normal switch or layer 2 switch. You have layer 3 switch, router, virtual router, access point. So this is uh, basically your modem, access point AP. Then you have firewall, IPS. So these all devices, for example, if you're considering firewall, you have the internet over here, and if you have your LAN over here, you might have to like connect your LAN to the internet, but you don't want anybody from internet to gain access to your LAN. So in those cases, what you do, you set an IPS or a firewall or both. So IPS is basically intrusion prevention system. It is kind of like firewall, but sometimes a bit better than firewall. It has ability to read through your data as well. Yeah, IPS is intrusion prevention system. So the thing about firewall is firewall usually what it does is it checks for the source, it checks for the destination, and then identify whether that packet should be permitted to enter your LAN. Whereas if you're considering IPS, what it does is it has ability to go through the content of that particular packet and identify whether that particular packet is like malicious or not. So that's a big difference. Both are used for security features. Okay. Similar to firewall, like similar functions of firewall, but at times a bit better than it. Okay, so that's what you have as intermediary devices. So the thing, as you can see over here, so you'll be having at least two connections, an entry point from the internet and an exit point to your system or your LAN. Same happens for IPS. Access point. So like if this is your modem, your device like tablet or phone will be connected to the access point. The other end of the access point is going to the internet. So it is enabling your connection to the internet. So same thing happens for all of these devices. You'll be having a laptop connected to a switch, which will be connected to the router, which will be connected to the internet or your LAN or whatever connection that you have. So in such format, you have a lot of different types of devices, mainly endpoint and intermediary devices. Okay. The next one, those two we already seen. Media, you can be an Ethernet link, serial link, a wireless link, etc. This is Wi-Fi. This is like long distance cables and all, mainly used to connect between routers or SD-WAN, etc. Ethernet link is your basic, internet link that you use, RJ45, etc. Then you have services. So the services can be network control, applications, softwares, protocol implementations, anything like that. For example, if you're using Zoom, that can be considered as an application software, part of services. If you have WebEx, that can be considered as the same. Teams, same thing. Or what else? You have Firefox inside your system. Again, a service, an application. So all of these kind of different types of applications or services or like uh, items that you can do any kind of process with can be considered as a service. Okay, so these are the major different components that you can note about like in your network. Okay, great. And let's say okay, we have a question, I think. Virtual router. So in some cases, you might require some like extra routing requirements, and you might not have the right, how to put this, devices for this at the moment. So for example, imagine a situation where you are using, like you want to learn something. Okay, you want to learn about routers, but you don't have the right components for this. You can't just go ahead and buy a router to learn about it, right? Because those things cost like 1 lakh, 2 lakh, etc. So just to learn about it, you can't use it. So what you can do is you can set up virtual routers, learn configurations on that, and you can even do the routings on that. Okay, so this is kind of like a software function that replicates all the functionality of your router. So basically all kind of layer 3 functionalities, it will be able to do that. So if you want to test something like that out, we have a couple of softwares like GNS3 on which you will be able to run a virtual router. So you'll be able to do all kind of routing on that particular router, like from basics to not just advanced, you can basically do everything over there. Packet tracer, no, packet tracer can't actually be considered as a virtual router because this is something that you use only for like learning purposes, not on an industrial level. So packet tracer, you can like you will be able to see all the functions of router over there, like from smaller to larger, everything you'll be able to see over there. The only problem is you won't be able to route actual packets, your actual packets that are going through your system, that you won't be able to patch it through the packet tracer. Because packet tracer, although it has all these functions, it is still a simulator. So it simulates the functions, but it can't actually do the functions. Whereas if you're having a virtual router, it can actually do that particular function. Like if you're sending a packet from here to somewhere else, you can even route that packet through this virtual router and then send it to that particular person. Okay, so virtual routers are actually having the exact functionalities of router. Whereas in case of packet tracer, you will be simulating all the functionalities of router. Okay, so that's the difference. Anyway, that was a good question. Like if packet tracer is same, because you have to know that know the difference between the simulation and the actual thing. Okay, so yes, coming back, let's see. Okay, so when you're setting up a network, there are a few characteristics that you have to always make note of when you're setting up any kind of network. So let's quickly go through that as well. Okay, somebody's asking IPS again. So I already mentioned it once, but again, IPS is basically known as intrusion prevention system. What it basically does is that it filters down packets that are coming into your LAN network from the internet. Okay, so it can do that based on multiple factors. So it is similar to firewall, whereas firewall, what it does is it filters based on the source and destination. When it comes to IPS, it checks for source, destination, as well as the content inside that particular packets. So if it is finding any kind of malicious content inside the packets that are coming in from the internet to your system, it will identify it, block it, throw out that particular packet and inform us about that. And the full form is again intrusion prevention system. Okay, hope you got it. Deep inspection, yes, kind of like that. So great. I hope you got that. And yes, the next one is characteristics of network. Sticks of network. Okay, characteristics of network. So, like when you're purchasing a phone or a PC, basically the specification list tells you the important characteristics of that device, right? Like this particular device can do get like 40 Mbps photo, or you can do image rectification, something like that, etc., etc. Lot of functionalities will be told to you. So when you understand each characteristics of a network, you can better understand how network is designed, how it performs, how it meets the user expectation, etc. So when you're considering a network, you can describe the qualities and features of a network by considering a few of the major characteristics, to put it simply. Uh, so first one is topology. Topology. So what is a topology? A topology is nothing but the arrangement of all the elements inside that network, like how it's arranged. So it gives you an insight into the physical connections and data flows among the devices. So in a carefully designed network, data flows are optimized and the network performs as desired. So let's say if you have 100 PCs, and you want to connect all of them together, or maybe if you want to connect 50 PCs together, then 20 PCs, then 20 PCs, then 10 PCs. All of them has to be separated. So based on those kind of requirements, you have to set up topology. So it's kind of like a blueprint. So you may have one router here. From that, you have a central switch. From that switch, you'll be having two other devices. What is this? Yeah, two other switches. And on this, you'll be having these all 50, maybe 25 here, 25 here. And from this router, you'll be having another switch. From that, you have your 20 devices. And here, another switch, another 20, and another switch, another 10 devices. So in such a way, you can divide it up and set it up. So it will be completely based upon the business requirements of that particular area. But what you have to do is you have to make sure all the like PCs are given in the right way. The topology is given in the right way. For example, layout like building, yes. So the layout will be based upon like that. Okay. So sometimes what happens is that, like if you are giving 20 from one switch and another 20, for this 20 is also connected to that switch. So maybe there can be some kind of data intersection or something like that could happen. Okay. If like it's not programmed correctly. So these kind of issues should be avoided. Okay, so if you have to separate something, you have to set up the topology based on that particular requirement. Okay, you should not try to make something like too hard over there. So for example, from this you have two switches, and from here you are connecting another for this 20 and all. That is not required. Okay, so based on our requirement, you can set it up, and it will also depend completely upon what exactly is the location of that uh, building, or how that particular people are sitting over there. So everything will be considered before setting up a topology, kind of like a blueprint of your network. Okay, so that is topology, and it gives you a clear-cut idea on how everything is set up, how the flow of the packets will be taking place, from which switch to which router the packet will be going, through which route the packet will be going. Everything will be noted down in case of topology. Whereas the second one is bandwidth. Bandwidth. So bandwidth, as the name suggests, basically helps you identify the speed of that particular device configuration. Okay. For example, how much data a particular link can manage, or how much packets can be passed from one device to another within that particular time. So that is identified with the help of bandwidth. So that is another characteristics. Each network should have the required bandwidth. So for example, if you imagine that you have a switch over here, you have a switch here, and you have a switch here. And you from here to here, you want to transfer a lot of data, maybe 500 GB per day. Here to here, you want to maybe send like 5 Mbps. So what you have to do is you have to make sure that this particular link has high bandwidth. This can be having low bandwidth. So depending upon the requirement of data transfer, you can set up any kind of bandwidth requirement. 100 GB. Okay, that's okay. That usually happens between location to location, like 100 GB per second speed and all. For example, if you have a location in, as I said before, Bangalore, and another location in Delhi, and you want to transfer data from here to there. So in those cases and all, you might be setting up 100 Gbps, 70 Gbps, etc. Other ones, we usually go for like 50 Mbps, 500 Mbps kind of a speed. Maximum I've seen is 2 Gbps. Like when companies are using it, because they don't want the employees to use the internet too much. So yeah, coming back. Different on our device, like PC has 10 Mbps. Different? Yeah, mostly I have seen 1 Gbps. Like sometimes the thing is that even though your network has 100 Gbps, 200 Gbps and all, your PC might not be supporting that speed. So that is also there. Like the NIC card on your system should also support this speed, right? If not, it won't be working like that. So yes, the second one was the bandwidth. And the next two are kind of correlated. So I'll just mention both of them together. Third one is availability. And fourth one is reliability. Availability and reliability. So availability indicates how much time a network is accessible and operational for a particular user. So this is mainly expressed in terms of percentage of time the network is basically operational. So for example, like if you're working, like if your company has a practice of only working from office, like work from office only. And to be honest, that is the best kind of company. The reason is once you finish your 9 to 5, and you won't be having access to their network. Like their network will be basically shut down. So that is the availability. Your working time from 9 to 5, that can be considered as the availability. So what? 10, 11, 12, 1, 2, 3, 4, 5, 8 hours. So 8 by 24. 24.